These are just dust caps. Inside we have screws. These screws are for adjusting the separation line. One of them adjusts the width of the separation line. If the separation line is too wide, it makes it narrow, or it can make it wider. The other adjusts the angle of the separation line. Sometimes the separation line is fatter on one side, and the screw, one of the screws adjusts that. You simply slightly turn the screw while looking into your eyepieces and adjust your separation line as desired. We have a variety of accessories. These are polarizing filters. This is considered an analyzer. It is a polarizing filter. You would put one on each side. A lot of times when you're looking at evidence that is very bright, you may need to see those scratches in greater contrast. That's when a polarizing filter may come in handy. I've inserted the polarizing filter into the LED light. There again, whatever you do to one side, you typically want to do to the opposite side. So this is polarizing the light. This is considered the analyzer. After I've tightened it down, there, now it's all the way tight. You take the bottom ring can be turned. This will neither tighten nor loosen. This simply rotates the polarizing filter, and it's considered an analyzer. So you can get cross polarization at this point, and at your cross polarization you have the least amount of light passing through and the greatest amount of contrast for some of the specimens. We also have a bullet holder. The bullet holder can be tightened down to the stage. Here's two screws, two screw holes. The bullet holder also has a variety of adapters, holders. These can be used for holding small bullets and positioning the cartridges. We also have coaxial light elimination adapters, one for each side. This hole is where the fiber optic attaches. This coaxial elimination allows the light to go straight down, which is perfect for trying to eliminate something like a shell casing, eliminating the inside of it. If you have an incident light off to the side, it's not going to get light down into it very well. So at this point, our fiber optics have came into the coaxial eliminator. The light is mirrored down and it's in the coaxial plane. Coaxial direction, same axis. So the light is on the same axis as the viewing path, the eye path. You can see the mirror inside. This microscope also has the ability to do bottom transmitted illumination. This is the adapter that's used for that. It has a mirror inside, so the light hits the mirror and goes directly up through the bottom, transmitting the light through the specimen. The best illumination source is this LED. This one really won't work on it. So you just got to adjust the bottom. You just adjust the LED so that it will illuminate into the mirror and reflect out. Same on the other side. One thing to do on this microscope is to make sure that your magnifications are the same. We have reticles, stage reticles. You could also call them a stage micrometer. Line them up so that they're in one direction. Make sure your magnification is set to the same on both of your objectives. For instance, turn it to 2x and turn it to 2x on the other side. Get both of these in focus, raising and lowering them until they can clearly be seen in the eyepieces. Make sure that they're aligned in one direction on both eyepieces, and then read them off. See if one of them is giving you a greater magnification than the other. Remember, you have two independent eye paths. This knob is used to adjust the magnification to get the magnification on the left equal to the one on the right. Turning it one direction increases the magnification, turning it on the other direction decreases the magnification of this side. Do that until the magnifications are equal. One thing to note, these LED illumination sources, they're only 5 watt. They're very bright. This is going to be most of what you will need. When you really need a much better illumination, then you can use these really powerful 150 watt plus 150 watt, 300 watt total illuminators on the back, fiber optic.